Good evening, welcome in RNQ Easy classes. Unit block number 1, unit number 3, Introduction to Cosmology. 3.1 Introduction. The unit tries to introduce to topic of cosmology. After studying the origin, nature and definity of the universe, it looks into the Indian and Greek cosmologies. Then it takes up some important issues in contemporary scientific cosmology. Our aim is to show the religious beginnings today's scientific cosmology. 3.2 Origin, Nature and Destiny. Cosmology, study of universe of Greek cosmos, cosmos meaning universe, and logia study. Its strict usage refer to the study of the universe in its totality as it is now, or at least as it can be observed now. Through the word cosmology is recent first used in 1730 by the rationalist philosopher Christian Wolff. The study of the universe as a long history involving science, philosophy, historicism and religion. In recent times, physics and astrophysics have played a central role in shaping the understanding of the universe through scientific observation and experiment. The physical cosmology is primarily shaped through both mathematics and astronomical observation. By the analysis of the whole universe, this discipline focuses on the universe as it exists on the largest scale and at the earliest moments. It is generally understood to begin with the Big Bang, that is thought to have emerged roughly 13.5 to 13.9 billion years ago. Cosmology 2011, from the beginner, scientific cosmologists proposes that the history of the universe has been governed entirely by physical laws. Theories of an objective universe governed by the physical laws were first proposed by Roger Bacon. Contemporary cosmologist Steven Weinberg endorsed the same sentiment. The universe itself acts on us as a random inefficient and yet in the long run effective teaching machine. Outward of looking at the universe has gradually evolved through a natural selection of ideas. Philosophical cosmology, as distinct from physical cosmology, that data from physical cosmology and focus on critical reflection as to the origin, nature, and density of universe. While metaphysical assumptions and implications are also brought into the between the domains of religion and science, stands the philosophical perspective of metaphysical cosmology. This ascent field of study seeks to draw intuitive conclusions about the nature of the universe, man, the divine, and their relationship based on the extensions of the set of presumed facts borrowed from spiritual experience and observation. Cosmology 2011. But metaphysical cosmology has also been observed as the placing of man in the universe in relationship to all other entities. This is demonstrated by the observation made by Marcus Aurelius of a man placed in the relationship. He who does not know what the world is does not know where he is, and he who does not know for what purpose the world exists does not know who is who he is, nor what the world is. This is the purpose of the ancient metaphysical cosmology and nature and of reality In some cases, views about the creation cosmology and the end eschatology of the universe play a central role in shaping a framework of religious cosmology for understanding humanity rule in the universe. 3.3 Indian cosmology. In Indian science and religion are not opposed fundamentally, are seen as a parts of the same great search for truth and inspired the sects of Hinduism, Buddhism and Jainism. Thus in the Hindu scientific approach understanding of external reality depends on also understanding the Godhead. In all Hindu traditions, the universe is said to preach from the goods fundamental to Hindu concept of time and space. Space is the notion that the external world is a product of the creative play of Maya illusion. According the world as we know it is not really real but illusionary. The universe is a constant flux with many levels of reality. The task of the saint is the find release moksha from the funds of time and space. Hindu Cosmology 2006. Therefore, one of the ancient Hindu books describes this after a cycle of universal solutions, the Supreme Being decides to recreate the cosmos so that we souls can experience worlds of shape and solidity. Very subtle atoms begin to combine, eventually generating a cosmic and that blows heavier and heavier atoms together souls depending on their karma earned in previous world systems potentially draw to themselves atoms that goes into an appropriate body. Hindu cosmology envisage the universe as having a cyclical nature. The end of each kalpa brought about by Shiva's dance is also the beginning of the next. Rebirth follows destruction and the cycle goes on. Thus in Hindu cosmology the universe is, according to mythological Vedic cosmology, cyclically created and destroyed. The following symbolic representation of the creation of the world by Brahma is insightful. The span of Lord Brahma, the creator, is 100 Brahma years. One day in the life of Brahma is called a Kalpa, which is calculated to be 4.32 billion years. Every Kalpa Brahma creates 14 Manus on after the other, who is turned manifest and regulate this world. This there are 14 generation of Manu in each Kalpa. One day of Brahma, each Manu's life consists of 71 Chaturi Agas, quarters of yogas or eras, which in turn is composed of our eras or yogas Satya, Tirtha, Dwapara and Kali. The span of the Satya Yoga is 1,07,000 to 8,000 human years. Treta Yoga is 1,296 human years long of the Dwapara Yoga 864,000 human years and the Kali Yuga 432,000 human years. When Manu precess at the end of his life, Brahma creates the next Manu and the cycle continues until all 14 Manus and the universe perish by the end of Brahma's day. When night falls, Brahma goes to sleep for a period of 4.32 billion years, which is a period of time equal one day. One day Brahma and the lives of 14 Manus. The next morning Brahma creates 14 additional Manus in sequence just as he has done on the previous day. The cycle goes on her 100 divine years, at the end of which Brahma persists and is regenerated. Brahma's entire life equals 311 trillion 40 billion years. Once Brahma dies, there is an equal period of on manifestations of 311 trillion for billion 40 years until the next Brahma is created HC 2011. The present period is the Kali Yoga or last era in one of the 71 Chaturyogi set of our yoga's eras in the life one of the 14 Manus. The current Manu is said to be the seventh Manu. As such, the Kali Yoga began in 3102 BC at the end of the Dwapara Yoga that was marked by the disappearance of Vishnu's Krishna avatar. The beginning of the new Yoga era is known as Yogadi and is celebrated every year on the first day Padyami of the first month Chaitra Manu of the 12th month annual circle. The Ugadi of 1999 begins the year 1921 of the Salivana era 5.01 Kali Yoga 1999 AD. The end of the Kali Yoga is for 26/8/99 years from 1/19/1921. Overview of yogas: Satya Yoga, Kartik Yoga 178 to human years. Treta Yoga 1,296 human years. Dwapara Yoga 864 human years. Kali Yuga 432,000 human years. 5,111 years have passed. 426,889 years remain. Kali Yuga started in 3102 BC. CE 2009 corresponds to Kali Yuga year 5.111. The Nasadya Sukta of the Rig Veda describes the origin of the universe. The Rig Veda's views of the cosmos all sees one true divine principle, self-projecting as the divine word Bhak, breathing the cosmos that we know from the monistic Hiranyagarbha of golden egg. The Hiranyagarbha is alternatively viewed as Brahma, the creator, who was in turn created by God, or as God Brahma himself, the universe preserved by Vishnu, the god of preservation, and destroyed by Shiva, the god of destruction. These three constitute the Holy Trinity, Trimurti. Once again, this creation-destruction cycle repeats itself almost endlessly, as described in the section above on Brahma, Manu, and the Yogas HC 2011. The Puranic view. The latter Puranic view asserts that the universe is created, destroyed, and recreated in an eternally repetitive series of cycles of Hindu cosmology. A universe endures of about 4,320,000 years. One day, Kalpa of Brahma, the creator, and is then destroyed by fire of water elements. At this point, Brahma rests for one night, just as long as the day. This process, named Pralaya, uh, cataclysm, repeats for 100 Brahma years, 311 trillion 14 billion human years. That represents Brahma span. It must be noted that Brahma is the creator, but not necessarily regarded as God in Hinduism, because there are said to be many creations. Instead, he is regarded as a creation of the supreme God or Brahma. We are currently believed to be in the 51st year of the present Brahma's life, and so about 158.7 trillion years have elapsed since the birth of Brahma or Brahma's death. It is necessary that another 100 Brahma years pass until he is reborn and the whole creation begins new. This process is repeated again and again forever. HC 2011 and Raman 2004. Both the Rig Veda and Brahmana, the Purana, describe a universe that is cyclical or oscillating and infinite in time. The universe is described as a cosmic egg that cycles between expansion and total collapse. Total collapse. It expanded from the concentrated from a point called a bindu. The universe as a living entity is bound to the perpetual cycle of rebirth, death, and rebirth. The Padma Purana discuss about the number of different types of life forms in the universe. According to the Padma Purana, there are 8,04,400 life form species, 9 lakh of which are aquatic ones, 2 lakh are trees and plants, 1 lakh 100,000 are small living species, insects and reptiles, 1 lakh are birds, 3 lakh are beasts, and 4 lakh are human species. HC 2011. Unlike the West, which lives in a historical world and is rooted in a timeless universe of eternal return, everything which happens has already done so many times before through in different guises. Hinduism arose from the discoveries of people who felt that they had gained an insight into the nature of reality through deep meditation and ascetic practices. Science uses a heuristic method that requires objective proof of mathematical theories, yet both have proposed similar centuries for the creations of the universe. Hindu Cosmology 2006. 3.4 Greek beginning. The Greek worldview gave us the basis of scientific cosmology. Closely tied to the pseudo science of astrology, it continued from ancient Greek through medieval Islamic civilization to 17th century Europe. CHP 2011. Plato and Aristotle. Underlying the Greek worldview was the philosophy of Plato. He sought a deeper level of reality than that accessible to the senses. He also pursued a simple theory about the universe which had incredible explanatory power. The result was a brief in uniform circular motion. This belief dominated the thinking of many Western astronomers and cosmologists for 2000 years. The task for astronomers was to ascertain the motions of the planets. Sky watchers in the ancient Middle East, Central America, and China made many observations from their tables of members. They devised scams to predict future movements, and he even, unlike the colorful Myths proposed by the Babylonians, Mayanas, the early Chinese sky watchers. It is no exaggeration to claim the scientific cosmology, the search of a picture of a universe that would make sense with no mention of divine belong with the Greeks. They sought to look beyond the patterns of numbers of something fundamental. Under Plato's influence, Greek thinkers attempt to devise combinations of uniform circular motion that would produce the observed motions which were far from regular. Greek philosophers scientists set themselves the task of envisioning the universe as a set of physical objects. Plato's pupil Aristotle came to dominate thinking in this field, where Platonist thought in terms of the idealized mathematics of two-dimensional circles. Aristotelians envisioned actually three-dimensional spheres. CHP 2011. Aristotle thought that rotating spheres carried the moon, sun, planets, and stars around a stationary Earth. The Earth was unique because of its central position and its material composition. All generation and corruption occurred in the sublunar region below the moon and above the earth. This region was composed of the four elements: earth, water, air, and fire. Beyond the moon was the unchanging and perfect celestial region. It was composed of a mysterious fifth element. Greek philosophers estimated the distance of the moon and even tried to calculate the size of the entire universe, which believed to be finite. The outer sphere of the stars carried them on their nightly course around the earth. The natural place for earthy material was down at the center of the universe. Earthy material tended to move to its natural place toward the center of the world. Flames moved upward to reach their natural place at the top of the sublunar region. There could be no other worlds scattered throughout this universe because their earthy nature would have forced them to move toward their natural place at the center, with the earth at its center and the sphere of the stars its outer boundary. The Aristotelian cosmos consisted of tidal more than our solar system. Claudius Ptolemy, continuation of the Greek tradition of Plato and Aristotle, is exemplified in the work of Claudius Ptolemy. He systematized hundreds of years of Greek geometrical cosmology with rigorous demonstrations and proofs. CSP 2011. Ptolemy wrote his mathematical treatise, later named the Almagest, in about 150 AD. He worked out geometrical systems of compound in motions on two dimensional circles to match the observed motions. The heavens were not made of rocks, material, or other earthly material, but of some divine classical material. This scope offered no obstructions to the passage of one part through another. In his later book, Platonic Hypothesis, Ptolemy used three-dimensional below stars arranged one within another and surrounding the earth. There was no empty space between the spheres. The thickness of each cell accommodated small motions in and out of the earth. The rotating sphere it carried the planet or sun of moon in its orbit around the earth. According to him, the spheres rotate because that was their natural motions. It was proper. Ptolemy believed to attribute a uniform circular motions to the planets because of disorder and non-uniformity were alien to divine things. The study of astronomy dealing with divine things was especially useful for elevating the human soul.
वो तो सेट का बेटा दवाई रखा था रात को कुछ डाला वो क्या कहते हैं सब छोटी छोटी बात नहीं रखते अभी चले
3.5 The Arab contribution. As the Roman Empire fell and civilizations in Europe collapsed, the rising Islamic civilizations rescued Ptolemy's cosmology and improved upon it. The entire system was transmitted block to the best as learning revived there toward the end of the Middle Ages. Translation revealed the transitions. Ptolemy mathematical treatise came to be called Greatest CHP 2011. This was this was translated into Arabic and preferred with the definite article, although also seen in words like algebra and star names like Aldebaran translated from Arabic into medieval Latin. Ptolemy book became the Almagest. The Arabs also taught the West Arabic numerals, the place value system of calculating using zero, which was invented in India, and many trigonometric techniques, all originally from India, and made important mathematical advances of their own. Islamic civilization enjoyed a high level of scientific work. Astronomy was important for giving times of prayer from the altitude of the sun or stars and the Kabbalah or scared ordinations. Worships anywhere in the world needed to know the direction of Mecca so they could face it while playing, and mosques were oriented toward the holy city. The astrolabe was the fundamental astronomical instrument, serving as a clock and navigational tool. Islamic princes also constructed giant instruments to measure the positions of planets and stars for astrological purposes. Among the Arabs and Persians were great calculators and mathematicians who worked to improve the cosmological explanations of astronomical measurements. For example, Nasir Daniel Tulsi and Maragha produced a particularly innovative additions to Ptolemy's circular motions. The Tulsi couple calculates a linear motion from a combination of uniform circular motion. CHP 2011. In this revelatory work on the solar system published in 1543. Copernicus used a strikingly similar device. Also, Copernicus used a model for the moon's motion identical to one devised 2 centuries earlier by the astronomer Ibn al-Satir in Damascus. Copernicus cited the works of Islamic astronomers and certainly learned from them. Historians are still trying to determine the full extent of his intellectual debt. More on the history of cosmology will be take up in the next unity. Since this is an introduction, we want to focus in some important them of contemporary scientific cosmology. 3.6 Some important themes of scientific cosmology. Cosmology study the universe as a whole, its birth, growth, shape, size, and eventual fate. Eventual fate. Contemporary cosmology began last century. The vast scale of the universe became clear in the 1920s when Edwin Hubble proved that spiral nebulae are actually other galaxies like ours, millions to billions of light years away. Batteries by 2006 we take up some important concepts and themes to initiate ourselves into contemporary cosmology. The Big Bang. Hubble found that most galaxies are red shifted, that is, the spectrum of their light is moved to longer radar wavelengths. This can be explained as a Doppler shift if the galaxies are moving away from us. Fainter, more distant galaxies have higher redshift, implying that they are receding faster in a relationship set by the Hubble constant. The discovery that the whole universe is expanding led to the Bang theory. This states that if everything is flying apart, now it was once presumably packed much closer together in a hot, clean state. A rival idea, the steady state theory, holds that new matter is constantly being created to fill the gaps generated by expansions, but the Big Bang largely trumped in 1965 when Arno Pangaeus and Robert Wilson discovered cosmic microwave background radiations batteries by 2006. This is relic had radiation emitted by not matter in the very early universe 380,000 years after the first instant of the Big Bang. Space-time curve. The growth of the universe can be modeled with Albert Einstein's general theory of relativity, which describes how matter and energy make space-time curve. We feel that curvature as the force of gravity, assuming the cosmological principle that on the largest scale the universe is uniform. General relativity produces fairly simple equations to describe both how space curves and expands. According to these models, the shape of the universe could be like the surface of a sphere of curved like the surface of a saddle, but in fact observation suggests that it is poised poised between the two, almost exactly flat. One explanation is the theory of inflation. Inflation this states that during the first second of existence, space expanded at terrifying speed, flattening out any original curvature. Then today's observable universe green Universe grew from a microscopic patch of the original fireball. This would also explain the origin problem, why it is that one side of the universe is almost the same density and temperature as the other batters by 2006. The universe is not totally smooth, however, and in 1990 the COBE satellite detected ripples the cosmic microwave background, the signature of primordial density fluctuations. These slight ripples in the early universe may have been generated by random quantum fluctuations in the energy field that drove inflation. Topological defects in space could also have caused the fluctuations, but they do not fit the pattern well. Those density fluctuations from the seeds of galaxies and galaxy clusters which are scattered throughout the universe with a formulas, large scale structure and scales of up to about a billion light years. All these structures form because gravity amplifies the original fluctuation, pulling denser patches of matter together. Batters by 2006 dark matter in experimental simulations of Big Bang, it is found visible matter does not supply enough gravity to create the structure we see. It has to be held out by some form of dark matter. More evidence for the dark stuff comes from galaxies that are rotating too fast to hold together without extra gravitational glue. Dark matter can't be like ordinary matter because it would have made too much deuterium in Big Bang mm, nucleosynthesis. When the universe was less than 3 minutes old, some protons and neutrons fused to make light elements, and cosmologists calculate that if there has been much more ordinary matter than we see, then the dense cauldron would have brewed up a lot more deuterium than is observed. Instead, dark matter must be something exotic, probably generated in the hot early moments of the Big Bang. Maybe particles such as winds weakly interacting massive particles, or less likely primordial black holes. Dark energy. Another dark mystery emerged in 1990s, where astronomers found that the distant supernova are surprisingly faint, suggesting that the expansion of the universe is not slowing down as everyone expected, but accelerating. The universe seems to be dominated by some repulsive force or anti-gravity which has been dubbed dark energy. It may be a cosmology's constant or vacuum energy or a changing energy field such as quintessence. It could stem from the strange properties of neutrons, or it could be another modifications of gravity. The WAMP spacecraft put the standard picture of cosmology on a firm footing by precisely measuring the spectrum of fluctuations in the microwave background, which for its universe 13.7 billion years old, containing 4% ordinary matter, 2.22% dark matter, and 74% dark energy. WMAP's picture also fits in planetary theory. However, Steiner test of inflation awaits and the detections of cosmic gravitational waves which the rapid motions of inflation out to create, and which would leave subtle marks on the microwave background batters by 2006. The density of dark energy is far smaller than the vacuum energy predicted by quantum theory. That is seen as an extreme example of cosmological fine tuning in that a much larger value would have turned apart gathering clouds and preventing and stars from forming. That has led some cosmologists to adopt the anthropic principle that the properties of our universe have to be suited for life, otherwise we would not be here to observe it. 3.7 Some unanswered questions. In the current cosmology, the biggest questions are still unanswered. We do not know the true size of the universe, even whether it is infinite or not, nor do we know its topology, whether, whether spacecraft around on itself. We do not know what caused inflation, or whether it has created a plethora of parallel universes far from our own, as many inflammatory theories imply, and it is not clear why the universe favors matter over antimatter. Early in the Big Bang, when particles were being created, there must have been a strong bias towards matter, which the which the standard model of practical physics can't explain. Otherwise, matter and antimatter would have annihilated each other, and there would be almost nothing left but radiation matters. By 2006, the fate of the universe depends on the unknown nature of dark energy and how it behaves in the future. Galaxies might become isolated by accelerations, or all matter could be destroyed in a big rip, or the universe might collapse in big crunch, perhaps re-expanding as a cyclic universe. The universe could even be swallowed by a giant wormhole, and the true beginning, if there was one, is still unknown because it at the initial singularity. All known physical theories break down to understand the origin of the universe. We will probably need a theory of quantum gravity matters by 2006.